Let's begin. Today's January 5th, 2025, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 2, 6, 13, 17, 19, and 21. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine compares it to the number 3. So should the value of triangle be less than 3, should it be equal to 3, or should the value of triangle be greater than 3? Criteria card B will take a look at our middle digit, the square digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at our middle and last digits, square and circle, and compare them. So should the value of square be less than circle, should they be equal, or should the value of square be greater than circle? Criteria card D will take a look at our 3-digit solution, and the Turing Machine will let us know how many evens there are. Are there no evens? Is there a single even? Perhaps 2, maybe even all 3 are even. Criteria card E will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F. Again, we'll take a look at our 3-digit solution, but this time it'll let us know a little bit about its structure. Specifically, it can inform us whether there's a pair, as in the example 131, or alternatively, there are no pairs, but there are 2 different cases. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card B. Okay, so the Turing Machine does not approve of my choice in square. I did pick an odd one, but since the Turing Machine does not agree with that, it's informing us that actually square should be even. So let's go ahead and type that up in our notes in section B, and we'll state that square is an even digit. And since it is even, let's go ahead and cross out the 3 odds. Okay, so I think the next thing I'd like to test is criteria card E. Okay, so again, the Turing Machine does not approve of my choice, except this time we are looking at both triangle and square and adding them up. So in my proposal, 3 plus 1 is 4. 4 is less than 6, but since the Turing Machine does not approve that, it must be one of the other 2 options. And that is that the sum of the 2 digits must be either equal to 6 or be greater than 6. So let's go ahead and type that up in our notes in section E, and we'll say that triangle plus square should be either equal to or be greater than 6. Well, since we've established that square is even, the only way we can have a sum that's equal to 6 is if triangle were also even. Otherwise, then it would have to be greater. So let's see. What can we say? So in looking at criteria card D, trying to think of, can we say that we have 3 evens? I don't know. Don't see anything that would disqualify. Sure, if we had 3 evens, we'd know that it wouldn't be 3, but it could still be an odd that's less than or greater than 3. And because you have 3 evens, it doesn't necessarily mean that square and circle would have to be equal. So yeah, I don't see any way to disqualify the number of evens. Let's see. Well, let's go ahead and test criteria card F. Okay, so in this case, the Turing Machine does agree with the proposal. Notice that in 314, all the digits are distinct, so that means that there are no pairs, and the Turing Machine approves of that. So let's go ahead and type that up, and we'll say that the solution has no pairs. But at this point, can we say that it's either they're all distinct or all the same? Well, I think we can say that it shouldn't be all the same, because if that were the case, then we would know for sure that square would equal to circle. So I'm pretty sure that we can say that we are looking at 3 digits that are distinct. Okay. All right. Well, that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So just as a reminder, we did not test criteria card A, comparing that first digit to the number 3. We also did not test criteria card C, comparing that middle and last digit, the square and circle. And we also did not test or query how many evens there might be. And of course, it's still a little outstanding whether the sum of the first 2 digits is 6 or not. But let's jump back to criteria card D. Now that we know that we don't have pairs and that they're all distinct, we can say for certain that there can't be 3 evens now, because since we're limited to just a 2 and a 4, if they were all even, we'd at least have a pair of evens if we had 3 of them. So for that fact, and of course, if you had a pair, then it would contradict what we just learned in the first round concerning criteria card F, that they're all different. So that means that obviously we do have a single even, so we know there can't be 0 evens. So it really falls to, is there 1 or 2? So, and if there were 2, it may make it easier for the sum to be 6, 2, and 4, or 4 and 2 in some order. And of course, triangle could establish which of the 2 evens it might be. Well, let's just say for the sake of argument that, yeah, we do have a sum of 6 and we do have a 2 and a 4. What could that mean for circle to be the odd digit? Could it be, if it was say 2, 4, I don't think it could be 1 or 3, because how would you distinguish between 1 and 3? They're both less than 4, so circle would be less than square. And similarly, if it was 4, 2, how could you distinguish between 3 and 5? 3 and 5 are both bigger than 2, so circle would be bigger than circle. So if anything, it might be something like 2, 4, 5 or 4, 2, 1, because I don't see any way to distinguish otherwise for that circle value. And again, that's if the sum is even. So let's see. So we could, have a proposal either 2, 4, 5 or 4, 2, 1. If we test the number of evens, that'll tell, that would at least confirm a little bit that, yeah, maybe we do have a sum of 6. So yeah, let's go with 2, 4, 5. Let's see what happens. So just to make sure, yeah, that middle digit is even. I'm proposing that perhaps maybe the sum is equal to 6, and yeah, 2, 4, 5 has no pairs. So let's go ahead and test that. Let's go ahead and test criteria card D. Okay, so it does not like 2 evens in the solution. So that means that, again, not likely to have 3. It can't be 0. So in fact, there's only a single even in our solution. So we'll type that up, that we're going to deduce that there's a single even. So the solution has a single even. So that means that both triangle and circle must actually be odd. So let's go ahead and then cross out the evens in both triangle and circle. So that means we are looking at a solution that is odd, even, odd. And I think now we can actually deduce that the sum should be greater than 6. Because again, if we don't have two evens in triangle and square, triangle and square, that means that we can't have a sum of 6. So let me go ahead now, cross out the equal, and I will write a note that we're deducing this this conclusion that the sum of the first 2 digits must be result in a sum that's greater than 6. Okay, so let's see. Well, if the sum is to be greater than 6, it doesn't look like triangle could be a 1, because 1 plus 4 is still less than 6. It could be 3. Yeah, 3, 4. Not 3, 2, but 3, 4. And then 5 would work for both of those. Okay. We also know that because square is even and circle is odd, they can't be equal. So they're definitely one that has to be greater than the other. And so let's see. Yeah, let's go ahead and test criteria card C. Okay, so it does not like the fact that square, in my proposal, 4 is less than 5, square is less than circle. It doesn't like that. So, and of course, as I stated, they can't be equal since one's even, one's odd. So we can actually deduce that square should be greater than circle. So let's go ahead and type that up. And again, that is in section C. And we'll say that we're going to deduce that square should be greater than circle. So let's see, how does that affect our values? So if square is to be greater than circle, I don't think square could be a 2. Oh no, I take that back. No, yeah, it could. 2 is greater than 1. I guess the only thing that we can cross out is circle 5. So if circle were 5, there's nothing bigger for square to be. And so, yeah, 2 is greater than 1, and 4 is greater than both 1 and 3. Let's see. Yeah, let's go ahead. Oh, yeah, now I was just thinking triangle 3. No, that's possible. Yeah, let's go ahead. Oh, you know what, though? Wow, this happened in a previous puzzle. I don't think I can test criteria card A because the last values that are valid are either triangle equal to 3 or greater than 3, and I did not pick that. How unfortunate. This is the second time it's happened, at least in recent memory, and I'm not sure how we can anticipate such a thing. So yeah, I won't be able to test it. Okay, well, let's see, what can we do? If triangle were 3, the only possibility would be 3, 4, 1. So let me go ahead. Let's see if it would be worth typing some of these possibilities. So 3, 4, 1, because again, remember the sum has to be greater. So it would be 3, 4, 1. And I believe that might be the only solution with triangle 3. No duplicates and square has to be greater. Okay, what if triangle is 5? So both would work, 2 and 4. So it would be 5, 2, but because it has to be, square has to be greater than circle, the only circle value that's valid would be a 1. And I believe that's the only possibility as 5, 2. Now 5, 4, on the other hand, it could be 5, 4, 1, or it could be 5, 4, 3. Okay, so obviously the last 3 all have triangle be greater. Okay, all of them do have an even middle digit square. All of them are, at least at the ones I've listed, have square be greater. They all have a single even. There's some, yeah, I would almost say that actually all of the 5s are ambiguous. You cannot tell them apart. Yeah. So that might have saved us going into a third round. It looks like those last 3 cannot be distinguished. Just double checking. Yeah. And, you know, obviously I formed them based on what we've learned so far, but yeah, those are all indistinguishable. So I'm going to say these are all ambiguous. So I'm going to cross them all out. And I'm going to type here that I'm going to deduce that triangle should be equal to 3. And so that would leave us with the solution of 3, 4, 1. So let's go ahead and type it up. So I do apologize, there is a bit of a lag. Okay, so let's go ahead and verify while this screen catches up. So we did say 341. Fantastic. Well, how did we do versus the Turing machine? Well, what could have been a 3-round solution only turned out to be a 2-round. And we actually did this 6 criteria card puzzle in only 5 tests. So I feel very, very confident that yes, we probably did beat the Turing machine. Well, we tested B, E, F in the first round. F was the only correct. And the only thing we had to test were C and D in the second round. So let's go ahead and type that up. So B, E, F in the first round. F was the only correct one. And then both C and D were incorrect. So that means our second round proposal, though wrong, obviously we still got the right solution. And so, wow, look at that. So we beat the Turing machine by 3 questions. Well, in some small part, look at all these deductions, right? So notice that criteria cards A, C, and E all have 3 possibilities. Obviously, the number of evens has 4. And so, there are lots of possibilities where, we wouldn't have gotten them. But look at these deductions. Very interesting how it all played out. And again, very fortunate that we did, by listing the values, we're able to think through and see that they were all ambiguous. You could not tell them apart based on, their structure and the obviously the assumption that it started with a 5. Well, how about you? How did you solve it? Did you use a different set of criteria cards, and did you discover anything interesting that you'd like to share? Please add those thoughts in the comments. If you liked the video, please do give it a thumbs up. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.